present you a proof. I don't do enough of that in here. I have you do a lot of work in class, and so I like to show you one all the way through. So to do that, I need to give you some definitions. The first one, I alluded to some of this before. A partition is if you have a set, and then you can break up that set into disjoint pieces. That's union up to be the original set, so you're cutting up that set into pieces, but their intersections are all empty. Then we call that a partition of S. You've seen this before. Z2 is a partition of Z. I took the number line and I split it into two boxes. There's nothing that overlaps in these two boxes. Yet if I union those two boxes, I get back Z. So Z2 is a partition of Z. I like to think of it as boxes when you move your house. You take all your kitchen stuff, you put it in a box, and you label it kitchen stuff. And then hopefully there's no overlap and you're not throwing pots and pans into the living room box. It does happen to me, but you guys will move a lot in the Army. So now I've ruined you. Every time you move, you think, oh, I'm partitioning up my house. That's what a partition is. Another definition is called the pigeonhole principle. It's going to be obvious where this name comes from. If you have a partition of a set with more elements than n parts, then at least one of those parts must have more than one element. This seems really obvious, but I'm going to use it in a theorem, and it's going to seem like, wow, that's actually cool how you use it. So let's say I have 6 elements here, and I'm going to partition it into 2. Well, that side has more than one element. So if I partition it, if there's a partition and there's more elements than the partition, then one of those partitions is going to have more than one element. Seems obvious. It's going to be cool to actually see it in use. There's something called the generalized. So in this case, n is 2, if you relate it back to the definition that I just gave you. So the generalized pigeonhole principle is if you have a set with more than k times n elements. This is great. When you have kids, you can actually think about this. So I used to give my kids cubes. They have manipulatives, give them cubes, and I'd ask them to divide them into equal sets, so you can teach them division right away. But then you can give them cubes, enough cubes that they can't partition them equally, and you can say, can't make them 3 equal sets, and then you can do this thing. They're going to find I've got leftovers. Hey, that's called a remainder. So you can teach division to really early, like they're 3 years old. You can start teaching them these things. Cool things you can do with your kids. I'll be hearing from you one day. I'm going to stay in touch. So in this case, I gave you an example. If I have 2 and 3, then I have 7 elements. Then if I try to put them into 3 blocks, then one of those blocks is going to have more than 2 elements in it. That's all it's saying. So you actually heard some of this before. You heard about Andrew Wiles talking about packets and breaking things up into packets. That's what he was doing. Exactly what he's doing. So this is like what he was talking about when he's talking about Fermat's theorem and the proof. And so there I have 2 + 1 elements right there.